Okay, guys.
Darn, I wish I had a book.
We have been talking about solving equations, and what is the answer to an equation called? Kyle.
The solution.
The solution. What does that mean? What is a solution? Alexis?
Like the one answer to the problem.
The one answer to the problem. Does anybody want to add to that or change that? Sanjana?
There could be more than one answers.
There could be more than one answer?
Yeah.
To an equation?
I think so.
You think so?
Yeah.
Can you think of an example?
Not right now.
Think about it. Raise your hand if you come up with one. Abhinav?
8x minus 6x equals 2x. That'd be an example of an equation that would have more than one answer.
Say that again so I can write it on the board.
8x minus 6x equals 2x.
Where did you see that equation? Because that one looks familiar to me.
I saw that we did the equation thing where we had to check the equations. I saw that on Amy's work.
Oh, you remember Amy. Who else was the other one? We talked about Amy's work and who else's work? Ben's work. Okay, so that was one where there was more than one solution that worked. I have, okay, is this equation true or false? I want you to think about it that way. Can you give me a value for x?
Pardon this final interruption. I'm ready for the 7th grade chorus, band, and orchestra students of 7th grade in the cafeteria, please.
You have a whiteboard in front of you. I only had enough for you and your partner, so there's 2 whiteboards and 2 markers. Do you need that to help you? Can you think of a value for x that would make this equation false?
Right? You're right.
What's the question? Can you give me a value of x?
3. For example, that would work, right? 12 plus 1.
Be creative.
20.4. 100.
Don't be too creative.
It'd be too creative.
I like it.
Huh.
Okay, may I have your attention, please? 5, 4, 3, 2. I like what I see when I walk around. Let me start over here. Drew, what did you guys come up with?
X equals 3. X equals 3.
X equals 3. How do you know that that's false?
Because if you substitute 3 for x, it would be 12 plus 1 equals 3, which is false.
You do not believe that 12 plus 1 equals 3?
No.
Are you sure of that?
Yeah.
Okay. Let's see. You guys had a negative answer. What did you put, Brianne?
X equals negative 17.
How do you know that's not true?
Because 4 times negative 17 is
figuring it out.
68.
Yeah, negative
68, and negative 68 plus 1 does not equal 3.
Okay, we have some more creative answers. I saw 2 groups with the same answer. What did you pick?
I did negative 5.
Negative pi. You don't believe that negative pi substituted for x would work?
I do not quite.
No,
How come?
because pi times 4 is like somewhere around 12, and then if you add 1, that's like 13, and that doesn't equal 3.
I like that. Philip, I like your estimation. I want you to read your number.
Okay. 207,652,943, and I can't really.
You want to change it a little?
Yeah.
Maybe not go out 17 places? Challenge yourself a little bit though. So you said 207,652,943
And 1,734 10,000s.
Very good. Nice way that you read that number. Emily.
Negative 2/3.
Negative 2/3. So that fraction doesn't work? Are you sure of that?
Yeah, because 4 times 2/3 is 8/3, and 8/3 plus 1 doesn't equal 3. I mean negative 8/3.
Negative 8/3 plus 1. Will that equal a whole number?
No.
So did you even have to figure out what negative 8/3 plus 1 is?
No.
No. Okay, I'm going to add another question. Clear your boards. Maybe let the other person write this time. Can you give me a value of x that makes this equation true? Don't, you two partners? Don't use those yet. Show your boards, raise your boards up. It's interesting to me that as much as you people dislike fractions, every one of your answers is written in fraction form. Andrew, was that a difficult equation for you to solve?
God,
What did you do to figure out the solution?
Well, I knew that 2 plus 1 equals 3.
You knew that 2 plus 1 equals 3. And then?
I had to do 2 divided by 4, which was 0.5 or 1/2.
I love that. Do you, let's see, Srilasya, your board changed. What does your board say?
X equals to 0.5.
How do you say that number?
0 and 5/10.
0 and 5/10. Abhinav, why is there, wait, before we continue. Why is 0 and 5/10 an answer?
Because 1/2 in decimal form is 5/10.
5/10 would simplify to 1/2. I like how you have both answers on your board. Clear your boards again. Okay, we're gonna do an activity now. And actually, look at the equation that I put up on the board. Is it similar to the equation that Abhinav gave us?
Yes.
Okay, what do you notice right away when you see this equation? Pranav.
That 2x plus x does equal 3x.
2x plus x does equal 3x. So what is the solution to this equation? Chloe.
X equals 1.
X equals 1. Raise your hand if you agree with Chloe. Pranav, can x equal 1?
No. Well, it could, but it could be any other answer too.
Okay, so you think there's more than one solution.
Yeah.
Do you remember what you said earlier, Sanjana? That the equations have how many solutions?
They can have more than one.
Well, what did you say at first? Or did you correct somebody? You added.
Someone else said 1.
Someone else said 1 and you said there could be more than 1. So is this a situation where that could happen?
Yeah. Yes.
Okay, you have a chart in front of you. And your chart with your partner, the same person you worked with yesterday, is always true, sometimes true, or never true. Tell me where this equation would fall into. 8x minus 6x equals 2x. Where would that equation fall? Emma?
Always true?
That equation would fall into always true. Could you explain why?
Because any number can substitute for x.
That's interesting. Give me, what was the equation we had up before? Was it 4x plus 1 equals 3?
Yeah. No, 2x plus x equals 3x.
Was it plus 1 or minus 1?
2x
Plus.
plus 1.
Where would that equation fall in your always true, sometimes true, or never true card? Slab. Alexis.
Sometimes true.
Find the pink card that I gave you. What does the pink card I gave you say, Myra?
It says 4x plus 1 equals 3.
4x plus 1 equals 3. Everyone put that up here. Set it down in the sometimes true column. To be able to say that something is sometimes true, what do we need to say about it? I used to be able to say something is sometimes true. What do we need to know about it?
We have to know that there's only one answer to it.
Okay, we have to know that there's, instead of only one answer, could you rephrase that?
There can be only an answer that works, because if it was like a half, it wouldn't work because 2 plus 1. Or if it was like, oh, but there are like 2 answers. So if it was like x equals 3, then 12 plus 1 equals 13. And
So does x equal 3 work?
yeah. Or no.
Tell me that again.
It doesn't. If x equals 3, 4 times 3 is 12, and 12 plus 1 is 13. So that wouldn't work, but half could work and 1 could work. Or only half.
Oh, my board needs to be calibrated. Okay. And you think that only 1/2 works. So to be able to say that something is sometimes true, you need to be able to give an example when it is true and an example when it's not true. What about never true? What do you think is going to happen in an equation that is never true? Havish?
Like it's only numbers, or like there's 2 x's and then x's cancel out.
Maybe the x's cancel out?
Yeah.
That's interesting. What else? Emily?
If the answer has no solution, it's incorrect.
So maybe you can't find any solution that would work for it. Okay? I love your thinking right now. Okay, this is what you're going to do. I have the directions on a slide up here, so if you get lost, you can go back to it. Here we go. So you have your partner from yesterday. Partner 1 is going to select one of the equation cards. We already placed the pink one. That was our sample one that we did together. So partner 1 is going to select one equation card. They are going to decide if it is always true, sometimes true, and never true, and tell the partner why they believe that. Give an explanation. I want a lot of mathematical discussions going on. Once you decide where it goes, partner 2 is going to either challenge your explanation if they disagree, or describe it in their own words if they agree. Once you come up with a definite place for your card, you'll set it on there and you will write an explanation next to it. Now you don't have a lot of space, so make sure you're writing small. And I don't want you to tape or glue these on there because you might be making changes later. So just keep your chart in one place so that you can make changes as necessary. Once you've chosen one card, put it down and have a definite explanation. Then you switch roles and partner 2 becomes partner 1. Okay? Make sure you're talking about the math. Whose did I steal? Oh, my own. Okay, go ahead.
Do you think it's more to describe it in your own words?
Alexis, were you saying that if X represented a different number on each spot? We talked about, and I think this is what Emily was getting at, in different equations, X can mean different things, like this equation compared to this equation. But if you're in one equation, X is only going to represent one value. Okay?
Wait,
Good job
I do one,
explaining
right?
that.
I'll do 3, you do 3, okay? So I just did 1. So this one will go with always true.
I can't read your handwriting. What does this say?
The only number that can be substituted in X is -4.
Why?
Because if you simplify it and then subtract, subtract, if you move this to the side, you get, well, maybe.
Before you erase that, who put this card here?
Me?
Okay. Did you agree with his explanation? You agree that X, what did he say, X equals -4. Tell me why. Why does X equal -4?
It was if X take 3 terms and take there will be 2 x's, and then if you take that there will be -8. So if you
I don't understand where 2x comes from. Can you explain that part?
it was 1 4 times 1.
We'll go with never true because then like x gets canceled out.
Well, why did you think it was -4?
The only way
Because I thought x was negative on the right side.
4 can't be if
Oh, when you substituted in -4, you thought it was negative, so you did the opposite?
lower than that, then it won't be.
Okay, keep talking about that one. I want to come back and replace that.
This is never true because it's on. You don't get it.
How did you find this answer?
Well, obviously the 6x equals x, that can't be true because I have to simplify, so that would just be 5x equals x and nothing.
So why didn't you put it in the negative column?
Well, because if you multiply something by 0, then it's always 0 no matter what you do.
Whose turn's next?
Mine.
Did he already challenge you or agree?
I agree.
Okay, so now who's going to pick the next card? Great.
3x minus 5 is 2x. That would work. I think I know.
It could only be 1. One would work.
Did you let her explain, or was it your turn?
Oh, it's a minus x. Subtract x from the
Whose turn was it for this card?
Subtract x. There's no x.
That's fine that you're writing. Okay. Okay, so tell me how you figured out that this one is
Okay, so it's never true.
No, I'm just asking you. I'm just questioning.
Oh, when we simplified it, it
How
was
did you simplify it? Tell me
x
that.
plus 2. We divided 2 to get 2x and 4. That'll be 2x plus 2.
Oh, so what is that called that you did on the left side of the equation?
We divided.
Okay, so why did you divide? What was the process that you were doing? I like how you said, why did you say distributive property? I like how you thought about it that way, because usually with the distributive property, we're multiplying both parts. Okay? So it's not a distributive property, but it's
7x plus 14 equals.
what did you do right there to make that x plus 2?
You can take this solution and then you can.
But what did you do?
We divided 2x plus 4 as a whole divided by 2.
Why were you doing it? What were you trying to do to that side of to that expression?
So that it would only be one line, so that it would be.
You're simplifying. That was awesome. And then, so once you simplified it, what did you notice?
That x plus 2 equals x plus 2.
Okay, so did you stop there, and that's when you decided it was always true?
Yeah.
I want you to think of, keep going, but I want you to think about when you have more than one card here, what do these equations have in common? Okay, so keep going. High fives all around?
Wait, I think like if we put 4 equals 4 there, we should.
Will you explain it to each other? All right.
Oh, this is the equation.
Oh, you took both cards.
Well, we were using them so we could show our work. So
Yeah. And you guys weren't really using
Oh, they did the explanation on the bottom.
Okay, tell me, let's see. These two equations look kind of similar, right?
Yeah.
Why did you say that this one is sometimes...
Oh wait, no, this is
Wait,
sometimes.
I'm not asking you to move anything. Why did you say that this one is sometimes true?
One.
this could ever work.
Then it would be. Oh wait, no, these are different. This is.
I don't want you to look at anything right now. Just look there. Tell me why this one is sometimes true.
That would be 4 equals 5.
Okay.
Like. True.
And 0 to 8.
Okay.
And then.
Okay, so then why isn't it always true?
6x equals x. Doesn't really make sense. 6 or something.
Oh, I like that. 6 of something would never equal 1 of something.
And then you have 6 pencils and then 1 pencil.
Are there any numbers that would work for? Did you try a positive number, right? Did you try a negative number?
Well, if it was a negative number, that would be, so pretend we do negative 1. So that would be negative x equals negative 6x. Or negative 6 equals negative 1. Which is not.
Okay, so did you try a number that's not positive and is not negative?
You can do 0 with, oh, so sometimes it's true.
You think it would be sometimes true?
I have a feeling that
Because if it was 0, then it would be 0 equals 0.
Okay. What about this one? Why is this one sometimes true? 10 over 2x
Because
equals 5. 10 divided by 2x
if we did
equals
5 over 1, so then we would cross multiply.
5. Oh,
So
okay.
then it would be 10x equals 10. So then it would be so we divide both sides by 10. So then x equals 1.
Steal that board from them, please.
negative x equals negative 8. So x equals
Excuse me, Sanjana. Thank you. Tell me what you just said.
So it's like you're doing 10 over 2x equals 5 over 1.
Okay.
So then you would cross multiply because there's an equal sign. So then it would be 10 equals 10x. So then you would divide both sides by 10. So then it would be x equals 1. Then it would be 10 over 2 times 1 equals 5. So then it would be 10 divided by 2 equals 5. And so 5 equals 5.
Good. I'm going to tell you that you have a couple. This column is awesome. There's a couple here that you need to switch around. So you look through it and see if you can figure out, now that we talked, remember we proved this one.
There's 600 Wait, you figure it out. This is never true.
You don't get it? Oh yeah, I'm guessing about it. It is sometimes true. Or never true.
That's our next step.
But 2, then it'll be 12 equals 2.
Yeah.
That made no sense. Yeah, so then, only 0 would work, so it'll be sometimes true.
Okay, did you find a time that it works?
X equals 1 over there, and then we'll put
Why does it work when x equals 0?
0 works. X plus 5. Yes, I already tried it.
Raise your hand, you're done.
Oh, because you subtracted x from both sides? Does that work? If you substitute 0 in? Why does it work when you substitute 0 in, Emma?
No, because we want to take the fraction out, so we'll multiply both sides like
So does it work when x equals 1?
that would be yes.
Why doesn't it work when x equals 1? Because 6 doesn't equal 1. So I agree with where you put it. Do you agree with where you put it? Yeah. Good.
I need to multiply it by 2 so that it will go away.
Let's say this one. I put this one in the never true.
Which one did you do last?
Because
Did you randomly pick this one last or did you put this one aside?
No, we just kind of
minus x equals x minus 1/2.
What did you do?
I'm saying, let's say x was, let's say 1. 1/2 minus 1 would equal negative 0.5, and negative 0.5 does not equal positive 0.5. Therefore, I would think that this equation could never be true.
I disagree with that. If x equals 1/2, that means half minus half equals 0. And then on this side, half minus half equals 0. So it would be in some way.
that's how you spell it.
I agree because let's say x is 0 with 0.
Hold on, before you, we'll talk about that in a second. What did you do?
That
How
would be
did you
half
solve that?
and then 0.
What that process is called?
I just proved myself wrong.
Did you use guess and check? You
Explanation.
did? That sounds very methodical. How did he solve it? Did he use guess? Oh, you tried guess and check. Well, what did he do to go through that process? please? 5, 4, 3. Awesome. I noticed that a lot of you are either done or close to done. And I'm even impressed by some of you that are done that are still looking at these and trying to decide where they go. Okay, I'm going to give you some hints. At the top of the always column, put a number 3. Above always, put a 3. And above never, put a 3. Anybody can read my mind about what those numbers mean, Chloe?
There's 3 always trues and 3 never trues.
Okay, I'm going to give you that hint. And this is what we're going to do next. You are at a group of 4 now. So instead of just having 2 brains to work, you now have 4 brains to work. Oh, geez, Matt. You'll be able to fix it. Okay, so now I want you to work with the other pair at your table. And I want you to compare where each of your equations fall. If you want to make a change, you can make a change. If you're confident with where they are, then you can tape them where they are. I will bring tape around to each group. You don't need to get up. Okay, so raise your hand if you have any questions. Okay, use the power of 4 now. Work together. Oh, let's think about that. What are positive numbers?
1, 2.
Can you define positive numbers?
They are above 0.
Above 0? And what are negative numbers?
Below 0.
So is 0 positive or negative?
No.
No. So it's just 0 has its own value.
Wait, Mr. Patelski, could you do 0 divided by something?
You can do 0 divided by 0.
Something divided by 0.
Right. What is something divided by 0? What's 5 divided by 0?
That would be undefined.
Undefined. Your calculator will even tell you that. That's when I always. That's something I even get mixed up. So you can try it in a calculator. Try 5 divided by 0. Your calculator will say wrong. You can't do it.
Error divided by 0.
But now try 0 divided by 7. See? Sometimes your calculators are pretty smart. Sometimes you need to be smarter than your calculator though.
I got x equals negative 0. So that would work. So that would be x equals half. Sometimes true.
How did you get negative 2x?
May I have your attention please? 5, 4, 3. There have been several questions about my friend Zero the Hero from several groups. Varun, is 0 a positive number or a negative number?
It's neither.
Why?
Because it's not, it's in the middle. Like, it's not negative or positive.
What is the definition? Hey, Bo, can you give me the definition of a positive number? Just in your own words. Positive number.
Number above 0.
Can you use a different word other than above? Luke?
Greater.
A number
0.
greater than 0. Do you agree with that?
Yeah.
Okay. 0. Positive number is a number greater than 0. What's a negative number, Matt?
Number less than 0.
A number less than 0. So where does 0 fall? Is it positive or negative?
It's in the middle.
It's neither.
It's neutral.
The other question I got was, could 0 be a solution? Could 0 be a solution to these equations?
Yes.
It sure could. Okay? I'm going to give you just 2 more minutes to work. You don't have to have it all finished. I'll just accept whatever you end up having taped on. Okay? 2 more minutes.
I say this is x equals 0. Or x is 0.
Divided by 0?
Now, he said that that anything with 0 and a fraction is
Show them both in your calculator. Show what your calculator does. When you do it. Okay, may I have your attention, please? 5.
Oh, this is always
4, 3, 2, 1. I asked Havish and Matt to pass out a worksheet to you. You'll notice that your assignment is the Why Are Equations True worksheet. And part of it, the first part, is an extension of what we did today. I want to know Do you understand when an equation is always true, sometimes true, or never true? So that's the first part. It says, I'll pull it up here. So it says, for what values of x is the equation true? Will you always have a number in that column for what values of x is the equation true?
No.
You might not. Okay? Then what I want you to do is reflect upon what your groups discovered today. How do you know when an equation is always true? How do you know when an equation is sometimes true? And how do you know when an equation is never true? If it helps you to use an example in those answers, that's fine. But what I'm looking for is for you to come back with a more general answer to share with your group tomorrow and with the class. Okay? I have a couple questions for you before I have you pack up. My first question, I asked this at the beginning of class, and I think I got about 2 hands up. Let me see how many hands come up now. What do we call the value of x that makes the equation true? Nishit?
Solution.
The solution. Okay, somebody give me that definition in their own words. What is a solution? Aditya.
The answer of an equation.
The answer of an equation. Anybody else? Kyle?
What solves for like the variable?
Reword that. Say it again.
What the variable is? What number the variable is?
What number the variable is? Good. And now I have another question, and this is something new. And this would be, I know a lot of you know this because you've done math outside of Granger. What do we call those equations that fall into the always true category? There's a special name for those equations that fall into the always true category. Does anybody know it? Okay, so here's what I want you to think about. Think about the number properties. Remember how we talked about the commutative property? Where's my poster? Oh, it's not up. The commutative property, the associative property, the distributive property. Which property is not on my poster that we talked about?
Identity.
Karthik? The identity property. And what does the identity property mean?
Oh yeah. What? No, I don't know.
You don't know?
Forgot.
Emily's going to help you out.
A number of plus 1, or plus 0 or times 1 equals itself.
Karthik, why is that called the identity property? Why is the identity property of addition, when you add 0 to a number, it stays the same?
Because it's the same.
What does that mean?
It stays the same and it's its own identity.
Oh, it has its own identity. Okay, so let me ask you that question again. Can you tell me another name for an equation that is always true?
Identity.
Havish is the only one willing to take a risk. Okay, Havish, Andrew, and Pranav. Say it on the count of 3. 1, 2, 3.
Identity property.
Well, it's not the identity property, but it's the same reason we have that identity property. Havish, what are those equations called? They're called identities, and we'll talk about that more as we move forward. Okay, so supply managers, please bring me your supply bins. If the tape doesn't fit in, that's fine. The other partner, bring me your worksheet.
You can have all of it.
Make sure you clean up your area. Pack up. Nice job today. You all impressed me.